Hi, my name's Joss. I'm based in Wacom's UK office here in Frome, and I'm here to talk to you about what's next for Wacom's DRM platform. Within the last decade, the advancements in communication technologies combined with the explosive growth of the internet, social media platforms means that it is now easier than any time in history to copy, distribute and share creative content with a worldwide audience. Whilst on the one hand, this is great from the perspective of visibility of the content, allowing a content creator to showcase their work globally, it also leads to several problems for those content creators who wish to maintain control over their content and how it is used. A simple example, and one that most people would be familiar with, is the scenario of the unauthorized usage of a photograph. For example, say I publish a photograph to my website with a disclaimer that the image should not be used commercially without prior agreement. A local newspaper could perform a Google image search of the area, come across the photograph hosted on the website, and decide to use that as the header image for a local story without contacting me first. In this scenario, if I were to approach the newspaper, it's quite difficult for me to prove that the image is mine in the first instance, and then to prove that they are using it outside of the agreed terms as stated on the website. In short, there are two big issues that would need to be resolved. Firstly, that the image has been used in an unauthorized or unlicensed manner. And secondly, that the photograph has not been correctly attributed to the photographer, meaning that I receive no credit for the work displayed on their website. Traditional DRM systems attempt to overcome these kind of problems by the use of proprietary technology, such as the content scrambling system found in DVDs. These systems typically encrypt the content, meaning that to view the content, a consumer must use viewing software that contains decryption keys to display the content. Whilst this does slow down the proliferation of unlicensed distribution and usage of content, it also forces a content consumer to use the proprietary formats and systems in order to view and interact with the content. By locking the content into a specific proprietary system, the content producer loses the benefit of widespread distribution that is provided by the combination of the internet, social media platforms, and open formats such as PNG. It's clear that although the fully open model does have problems, taking a closed or hard DRM approach has too many disadvantages to be appropriate for a modern digital content creator. Even in this very basic example, it's clear that we need to fundamentally rethink the way that digital content can be protected whilst maintaining the portability of the formats. Before we consider a new solution to the problem, we should first understand the full scope of issues that are faced within the creative industry when it comes to how creative content is distributed, shared, and how contributions and credit are recorded against a particular piece of work. In addition to the problems I gave in the previous example, there are a number of other issues that are commonly faced within the creative industry as a whole when it comes to sharing digital content. The first of these issues is due credit in the creative production. In the very early days of 2D animation, it was common that a small number of, say, 2 or 3 artists would be involved in the bulk of the production of a particular piece of work. And in these cases, it was very easy to keep track of who contributed to a particular piece of work, and due credit would be applied to every member of the team. When it comes to more modern 2D or 3D animation workflows, creative content may pass through multiple artists, all of whom contribute to the final piece of work. For example, you may have concept artists, inking artists, colouring artists, animators, VFX artists and compositors, all of whom contribute to the production of a final animation. With the current approaches, there is no reliable way for the contribution of each artist to be recorded accurately against the final work. This often means that credit is only given to the big names that are part of the production, and the lesser-known artists within the process do not have their contribution to the work fully credited in the end result. This means that although an artist may put their contribution to a piece on their portfolio, they are unable to prove that they were really involved in the production, as there is no accurate record of their contribution to the work. The next big issue that is faced is the issue of IP sharing. It's very difficult to manage the sharing and ownership of IP between multiple artists. Currently, this is handled almost exclusively by direct communication and specific agreement for a particular piece of IP. What this means in reality is there are situations that arise where consensus between the multiple parties that have licensed a specific piece of IP cannot be reached. This prevents that piece of IP being used in further derived works. This is a direct result of there being no predefined frameworks for content sharing and usage in the case of shared IP for digital content. Related to the topic of IP sharing is the topic of traceable sources. An artist will normally build on the work of other artists either directly or by influence. If an artist wants to correctly credit the source artist, or indeed any works that that artist has used, it can be difficult to trace the original artist. In addition to this, even if an artist grants permission for the derived work, proving that this permission has been granted is extremely difficult, as there is no trusted chain of agreements to prove the existence of the permission. Another issue that is commonly faced is the issue of authenticity. How can a digital artist prove that they have produced or contributed to a particular piece of work within their portfolio? Currently, in the case of dispute, it's very hard for an artist to prove beyond reasonable doubt that they are the original creator or that they have participated in the production of a specific piece of work without a lengthy and manual validation process by the party who is questioning the authenticity of the work. Ideally, any system should be able to provide an artist with a way to prove their ownership or contribution to a piece of work from the work directly or directly from their digital portfolio in an open and digitally verifiable manner. What becomes clear from our discussion so far is that thinking of DRM as a system to protect one particular artifact, such as a photo or a digital painting, only solves a very small part of the problem. What we need is a system that provides a secure and verifiable way of mapping the relationships between concepts, content, and the content creators. This concept of a secure relational web connecting the pieces together is the very heart of the Wacom DRM system. At a conceptual level, each entity or node in the web has a unique ID. This ID points to a publicly accessible metadata document that contains details of the entity, including the links to other entities that the document is related to. This document is also digitally signed to ensure the integrity of the data within the document. Underpinning the system is blockchain, which is a decentralized public database that stores transactions in a verifiable yet permanent way. We use blockchain to store each of the unique identifiers for each node within our web. The identifier itself is stored as a decentralized identifier, or DID, which is a globally unique address that can exist across multiple blockchains and distributed networks. Each DID resolves to something called a DID document. The DID document contains the set of data that describes each node, including the owner, the relationship or links to other nodes within the web, and other additional information, such as licensing. These documents are also cryptographically signed to maintain data integrity and prevent anybody tampering with the record. In order to link the digital content itself to an ID and the associated document within the web, the Wacom DRM system provides digital watermarking technology for common 2D and 3D formats. This watermark enables a consumer or an interested party to take the content and retrieve the ID of the node. Using this ID, the associated document can be retrieved, and from here, the web can be browsed to explore the relationship between the content and all other pieces of related content, IP, and the contributors. A digital watermark is a marker that is added to digital content, normally to identify ownership or copyright of a particular piece. In general, the taxonomy of digital watermarking schemes is ordered according to visibility, robustness, and the embedding approach that has been taken. Visibility refers to how perceptible a watermark is to the human eye, where in general a less perceptible watermark tends to be less robust than a visible one. The robustness of a watermark refers to how detectable a watermark is after the host content has been modified. For example, a fragile watermark will be undetectable even after the slightest modification of the source material, whereas a robust watermark will survive content modifications such as JPEG compression, rotation, cropping, additive noise, or quantization, yet still be able to be extracted from the document. Wacom's watermarking technologies are both robust yet imperceptible, ensuring that we maintain a strong link from the actual content itself to the associated entries within the relational web. In order to link an artist to a concept or content entry within the relational web, the Wacom DRM system employs the concept of self-sovereign identity, or SSI, to represent the contributor within the system. SSI uses the DID architecture approach in order to provide a decentralized mechanism for user identification. This provides the ability for a person to hold, manage and control their digital credentials in much the same way as you do with physical credentials such as a driving license or an ID card. For SSI, a user first uses a secure wallet application on a trusted device to generate something called a public-private key pair, and the private key is then stored safely within the secured device. The public key is then published to an SSI-enabled blockchain such as Sovereign that generates an associated digital identity or DID for the user. This DID contains the public key and is available for anyone to view. Once this has been published, a user can request a trusted authority, such as a state passport agency, to produce a validated digital identity claim. The trusted authority issues a verified credential, say for example a digital form of a passport, signed with the authority's private key, and this claim is then countersigned by the user's private key and stored within the user's digital wallet. When a service provider requests this information, a user can either present the whole claim or a subset of the claim, and the service provider can validate the authenticity of the claim by verifying the public key signatures of the user ID and the issuer ID using the public keys present on the blockchain. This mechanism also allows a user to track claims that they have issued to service providers and revoke them at any time as required. Within the context of the Wacom DRM system, a DID document within the relational web contains an entry that defines the controller or owner of that particular document. The owner entry of the document contains the user DID of the digital identity for the content creator, providing the cryptographically secure link for the artist into the relational web. Taking the concept of SSI one step further, the Wacom DRM system provides a mechanism of linking the digital identity of a content creator to the creator themselves by the use of our biometric signature technology. Our signature technology allows the user to capture their handwritten signature using a stylus or tablet device such as the Wacom Intuos Pro. Although the captured signature may look like a static image, the data that is captured is actually a complete record of the pen movement against time, including when the pen is positioned above the tablet. The FSS format is then used to store this pen data along with metrics of the device that was used to capture the signature in a forensically secure and tamper-proof manner. In addition to the capture system and format itself, Wacom also has an advanced biometric signature verification technology called GSV that enables us to determine if a biometric signature that has been captured is a true likeness of another signature or is in fact an imitation. During the registration of a new entity within the Wacom DRM system, a content producer can add a handwritten signature to the upload, and this data is recorded in FSS format within the DID document on the relational web. If, at a later stage, the physical link of the artist to the digital ID associated to a particular entry within the relational web is called into question, then the Wacom GSV system, in combination with SSI, can be used to prove the relationship between the artist, the digital identity, and the content itself in the following way. The artist captures a fresh signature and digitally signs the signature or claim with their private key. This claim is then submitted to the verification system of the Wacom DRM system, which will validate the provided signature data against the public user record. Then, it will use the GSV engine to compare the newly captured biometric signature against the biometric signature that's recorded within the DID document on the relational web. If the verification is confirmed, then this validates that the user in the real world is indeed the owner of the digital identity listed within the document record, and the content creator or owner for the particular entry within the relational web. This gives us verifiable links at all stages between the physical world of the creator using the Wacom biometric signature technology, then using SSI with their digital ID to link the content creator into the relational web of the DRM system. The Wacom watermarking technology enables the link between the content itself and the relational web, and by using the concepts of DID and DID documents, we can ensure that the relationships defined within the web are cryptographically secure and verifiable. Now that we've taken a brief look at all the technology that makes up the Wacom DRM system, I'd like to quickly give an example of how this technology works together to solve the issues outlined at the start of the presentation. For the purpose of the example, I'd like to take the scenario of a texture artist adding a new piece of work to their portfolio based on the work of a 3D modeler and a concept artist, and having the chain of attribution and permissions being provided by the Wacom DRM system. Let's start our story with the concept artist. As the artist wants to be able to correctly attribute their work, they create a new entry in the Wacom DRM system by uploading the concept sketch along with their digital identity and a handwritten signature. A new transaction is performed on the blockchain to create the DID for the node within the relational web, and the DID document is created containing the details of the concept, the artist's SSID, some human-readable metadata, and the FSS signature that was captured during the upload. The DID document also outlines the license for the work, which in this case states that it can be used royalty-free in derived works provided that the concept is correctly attributed to the concept artist. The final stage of the process is that the DRM system returns a watermarked copy of the concept sketch, which the concept artist then uploads to an art sharing platform. Next, a 3D artist sees the concept sketch on the art sharing platform and decides that they wish to create a 3D model based on that concept. The first thing they decide to do is register their work in progress on the DRM system in order to record the credit to the concept artist. The artist provides their digital ID, the 3D model, the FSS data, and the list of IDs that the work is derived from to the DRM system. The system then creates a new DID on the public blockchain and a new document within the relational web for the 3D model. This document contains an entry in the derived from section that lists the DID of the concept work, creating the link within the relational web between the 3D model and the concept sketch. This means that both entities are digitally and cryptographically linked together. A watermarked version of the first version of the 3D model will be returned to the artist, but the artist decides that they need a little bit more work before they're ready to publish the model to their portfolio. Once they finish the model, they can upload a new version of the model to the DID system, but this time they simply provide the DID ID for the document for the previous upload. In this scenario, a new entry within the version block of the DID document on the relational web is created, and the model that has been uploaded will return with a new watermark that contains not only the ID of the document that represents the node, but also details of the version block within that document that is related to the specific version of the model. The 3D modeler then takes this model and uploads it to their online gallery. An aspiring texture artist is looking to expand their online portfolio, and although they are very good at texture art, their 3D modeling skills are not quite up to the same level. In order to use somebody else's 3D model as the basis for their work in their portfolio, they need to be able to clearly demonstrate they have permission to do this. As the 3D artist added their model to the Wacom DRM system, the texture artist can already see from a permissions and licensing point of view that the model will make an excellent base for their work. The texture artist creates their final textured piece and then in the same process as the other artists uploads this piece to the Wacom DRM system and receives back the watermarked art for their portfolio. When a work is presented to a potential client, that client can take the work directly and upload it to the Wacom DRM system. They are then presented with a full history of the work, including full credit to the works that inspired or provided input to the work, the licensing terms for each of the pieces, and the source artists for all of these particular source works. It's easy to see how the example of the texture artist's digital portfolio could be expanded or changed to solve all of the problems that we outlined at the start of the presentation that are present within the creative industry when it comes to sharing digital content. The relational web, watermarking technology, and SSI combine together to enable the flexibility of open web distribution backed with a trusted and cryptographically verifiable history of contribution, licensing, and IP sharing for digital content. The Wacom DRM system truly gives you the best of both worlds. I hope that you found this presentation interesting, and if you have any questions or would like any more details, or indeed if you'd like to help us shape the future of the project, please feel free to contact me directly by email and I'll be happy to connect with you. Thank you very much for listening, and I hope you enjoy the rest of the presentations from Connected Inc. 2020.